Okay, so in part B, right, we're asked to find the greatest height of the particle above the point of projection. So this particle shoots up, doesn't it? And we want to know how high it gets, okay? And if you think about it, okay, as it gets to, say, its highest point, say the highest point is there, as it gets to it, it's got to slow down, isn't it? Okay, because if it's going fast, it's just going to keep on rising. But what eventually happens, because gravity is working against it, right, slowing it down, it will obviously slow down, won't it? Okay, slow down until it reaches its max height. And at the max height, its speed is going to be 0. Okay, so we can say, look, at max height, its final velocity, if you like, its speed will be 0. We can use these initial conditions there to work out what the height is. So I'm perhaps using, perhaps we can use v squared equals u squared plus 2as. Okay, so v will be 0, so it'll be 0 squared. U will be 22.05, so square that, plus then 2 times then acceleration, remember it's working against it, so that's minus 9.8, and then times then s. Okay, so then we can figure out these numbers. 22.05 squared is, so that's 0, that's 486.2025, that's minus 19.6 times s. So if you take it over and if you take that over, you'd have 19.6 here, wouldn't you? 19.6 s here, positive. So then we can take the 19.6 down and divide, and we get 24.80625 meters. Okay, so maybe we'll round that to one decimal place. It's good to write the whole answer down though. Okay, so we've got the max height. Then it says part C, determine the speed and direction of motion of the particle 3 seconds after projection. So, when t is equal to 3, okay, we can work out velocity, yeah? Okay, that's what the question is asking. So if we use v equals u plus 8t, so v will equal 22.05 again, plus then, now remember, a is minus 9.8, isn't it? Because we're taking upwards as positive, so minus 9.8 times then the time, which is 3 seconds. So we get, let's work that out, minus 7.35 meters per second. So you've got a minus out, and that's telling you now the direction of this particle, right? In other words, it's going in the negative direction. And remember in the question, we defined upwards as positive, didn't we? Upwards as positive. So it's on its way down, basically, when you see a minus velocity. It's saying the direction it's going in now is opposite to positive. So we can say the speed is 7.35 meters per second. Okay, so we always write speed as a positive, because it's like the size of it, the magnitude. And it's going downwards, okay? So going down. Okay? So we've done that there. The other thing to note as well, the whole journey in part A was 4.5 seconds. Okay, so it takes 4.5 seconds for it to go up and then fall back down again. Right, now because it's symmetrical, okay, if it takes 4.5 seconds to go up and then down, you can halve that to see how long it takes to go up. So half of 4.5 is 2.25. So it should take 2.25 to rise and then 2.25 to fall. And the point is, when t equals 3, that's greater than 2.25, isn't it? So it must be on its way down.